This is a battleship built in America 100 years ago. Engineers designed a special catapult to launch planes from the deck. It consisted of a track and a 6-meter-high wooden tower. The tower had a heavy weight on top. When the weight fell, it would pull the rope connected to the track to move the plane, achieving the speed necessary for takeoff. However, the catapult had problems soon after installation. The deck could not withstand the heavy weight and was damaged by multiple impacts. Therefore, engineers tried to store compressed air from torpedo launchers in cylinders to provide thrust for the catapult. When the plane was ready to take off, compressed air would be injected into the bottom cylinder, pulling the rope connected to the track to launch the plane. But the power of the compressed air alone was not enough to launch planes heavier than 800 kilograms. For this purpose, engineers used pulleys to multiply the pulling force of the ropes. Thus, the airplane can take off smoothly on a 30-meter track. Since the catapult occupies the entire front deck, the airplane can only land on the water and must be pulled back to the ship by a trolley each time. This severely affects the battleship's maneuverability. To allow planes to land directly on the deck, British engineers built a larger vessel, although the front end of the deck had enough space reserved. However, pilots still need to possess excellent flying skills to avoid the control room in the center of the ship. Any mistake would result in them flying off the deck into the sea. So engineers moved the central control room to the right side of the battleship. The redesigned deck, however, caused a weight shift, leading to the ship tilting. For this reason, engineers had to find a way to balance the battleship. First, they filled the portside tanks, using the fuel's weight to counterbalance the control room's weight. But as the fuel was consumed, the battleship began to tilt again, so they moved the hangar to the port side. However, with the increase of crew and equipment, the hull tilted to the right again. After 20 years of repetitive testing, engineers finally extended the port side outward and shifted heavy equipment to balance the battleship. Just like that, the foremother of modern aircraft carriers was successfully launched in 1937. It could accommodate about 50 fighter jets. In an effort to increase the number of planes, after filling the hangar, they parked the excess fighters on the deck. This caused pilots to lose control of speed during landing, crashing into the parked aircraft and causing accidents. As a result, the engineer installed an arrestor gear on the deck. It is composed of hydraulic cylinders and pulley systems to suppress the momentum generated when the aircraft lands. Now, although aircraft carriers can safely land fighter jets on the crowded deck, this also makes the deck a primary target for enemy fighters. Once the deck is damaged, aircraft will be unable to take off or land. As a result, engineers used armored cylinders for decking. Now, although bombs cannot penetrate the deck, the extensive use of armored cylinders makes the aircraft carrier top-heavy, thus reducing its stability. To make it stable, it is necessary to make the aircraft carrier wider, but a wider hull encounters more resistance. Therefore, engineers increase the length of the aircraft carrier to keep the hull streamlined, just like that. Thus, the weight and size of the aircraft carrier nearly doubled. However, the larger size makes aircraft carriers easily targeted. For this reason, engineers designed a special remote radar detection aircraft. It scans the sky and displays all intruders in the area on the radar, allowing escort fighters to intercept precisely at the first instance. Even if the intruders evade, escort fighters cannot approach the aircraft carrier due to the deck's defensive cannons that can destroy anything within an 8-kilometer range. As the aircraft carriers continue to improve, fighters evolved from early propeller planes to jet fighters. The faster, larger jet fighters made safe landing, once again a difficult task. Due to their high speed, pilots find it hard to get the correct landing angle, easily causing the fighters to crash into the deck or the stern, caused a severe accident. The engineers calculated the optimal landing angle, then installed a laser beacon on the deck, and via a reflector, fixed the light on the optimal landing angle. In this way, pilots just need to stay within the light's range to land safely, but this method overlooked the impact of the waves, causing the laser beacon to sway back and forth. Because of this, engineers fixed the reflector on a gyroscopic mount, so no matter how turbulent the waves, the laser signal remains at the safe landing angle. Now, although aircraft carriers are bigger and faster, the fuel only allows them to operate for 3 days. Because of this, engineers installed 8 nuclear reactors in the middle of the carrier. They utilize the energy released from nuclear fission to heat water to generate steam. The steam then passes through pipes into the turbine set, causing the turbine to rotate and drive a huge gearbox, then drives the propeller, providing the aircraft carrier with a continuous supply of power. Due to the numerous nuclear reactors, engineers had to use hundreds of tons of lead to encase the reactors to protect the crew from radiation hazards, but this also made the hull subject to gravitational forces, causing the keel to bend. Thus, engineers had to redesign the interior of the aircraft carrier, using a steel leather honeycomb structure to reinforce the keel. Just like that, the world's largest aircraft carrier was born in 1961. Its 8 nuclear reactors inside are able to meet the electrical needs of 500,000 people and enable it to sail on the sea for 20 years.